Dear students, until now we have discussed that we need to be critical in identifying or discovering the algorithms. However, there are different strategies available in the world which can be used to find the solution of a certain problem and to come up with the algorithm to solve that problem. So, in this module, we will be discussing some of the strategies, and those strategies which we will discuss today are two. One is called reverse engineering, and the second is called look for related problems. So, what is reverse engineering? If you have the exact output which you already have and you have the exact input. So, if you want to learn that how this output was constructed or generated and you want to reach to the initial input, this means that the steps which you will be following backward, those would be placed in the reverse order to become an algorithm. So for example, you have an input here and you have an output here. So you do not know that which steps were followed to reach to this location. But you can try to go from this position to backward position. So coming to this position, and then you can learn over this transition that which steps need to be followed in the reverse order to become the algorithm. So this is one of the problem or example which we have already discussed in one of the previous modules, the paper folding to make the bird. So let's see that if you have such a problem that you have the paper and you have come up with the bird. So then to understand the algorithm that how paper was converted to the bird, you need to unfold the bird to this, to this, to this, to this, and so on, and going on the backward direction, you can reach over here, and then you can learn over the period of time that what step was followed to make this as this thing, and to make this as this thing, as to make this thing as this thing, and so on. So this is basically one strategy of reverse engineering, and that is applicable when you know that what is the exact output and what is the exact input, and you want to go from output to the input. So then the next strategy is look for the related problems. And this is basically, this technique is a particular value in the context of program development. So when you want to develop your program, then nowadays you need to learn that what different strategies are available in the world. Normally you are not going to discover the algorithm or the program nowadays. Whatever you want to do nowadays, you try to identify the related programs and algorithms which are available openly in the market, and then you are using that algorithm to solve the similar problem you have. So program development is not the process of solving a particular instance of problem, but rather of finding a general algorithm. This is very important. Let's have an example of it. So for example, if you have these four names, Abida, Umar, Ahmad, and Aisha, and you want to sort them. So for example, first procedure would be that you need to put Ahmad between Abida and Umar. So this will become Abida, Ahmad, Umar, and then Aisha. And the next step would be putting Aisha between Ahmad and Umar. So this will become Abida, Ahmad, Aisha, and Umar. So first you try to switch, or you try to put the third element between first and second. So first step was putting third element between first and second, and then putting last element between second and third. Put last or fourth between second and third. So this was the algorithm that sorted this list. However, the same algorithm cannot be applied when we have different input. Can you apply the same procedure? For example, put third element between first and second. Can you do it? Like Awais can be put over here. Khalida, Rahman, Awais and Waqas. So we cannot put Awais between Khalida and Rahman because Awais should go before the Khalida. So this means to rearrange, to sort this name, you need to put third one at the first position. This means if we come up with this algorithm cannot be applied to the next instance of problem. And similarly, there could be number of other names which can come. You are nowhere to make them properly sorted. So this means you need to find an algorithm which is actually the sorting algorithm. And what the sorting algorithm do, that sorting algorithm finds the name that is basically that should be come at the first location. So it will analyze all of the names and put the name at the first location, which is the smallest one lexicographically, and then it will keep moving in the same direction. So that algorithm can be applied over here and here, or any other data or any other instance you find, that algorithm can be performed. So this means that we do not try to find the algorithm that is going to solve one particular instance. In fact, we try to find the related algorithm which can be applied on all of the instances of similar problem. For example, we covered sorting. So this algorithm can be applied on any kind of data. In fact, this may happen that you are going to sort the name of all Pakistanis. So you have in crores all of the Pakistanis, and then you are going to arrange them by name. So your algorithm should be able to arrange all of them properly, sort them properly in the lexicographical order or in alphabetical order. So that algorithm should not be biased or should not be only applied on one particular or two particular instances. It should be solving generalized problems of that particular shape or procedure.